as you can see in this diagram, these are two cylinders. The two cylinders are placed coaxially. That means the centers of both the cylinders are same. Okay, the axis passing through the center is the same. The inner cylinder has a radius of R1. The outer cylinder has a radius of R2. I hope you understand from this diagram. This is the inner cylinder and this is the outer cylinder. Now, the inner cylinder is solid, okay, and the outer cylinder is hollow. That means there is some space available between the inner cylinder and the outer cylinder. Now, what is done is the space between the inner cylinder and the outer cylinder, that is this space, and it runs into this direction as well, that is filled with a fluid which is viscous. The coefficient of viscosity of that particular fluid is not given to you. Also, the density is not given to you. The only information that has been given is that this space is filled by a fluid which is viscous. Okay. Now, what is done is we will be studying two cases. In case 1, the inner cylinder is moved with a velocity of v0 in this direction, that is along the axis, while the outer cylinder is kept static. I hope you understand. So the outer cylinder is kept static and the inner cylinder is moved with a velocity of v0. In case 2, the opposite is happening. That is, the outer cylinder is moving with a velocity of v0 and the inner cylinder is kept static. Okay? So what would happen? If the fluid is viscous, a velocity gradient would be created. That means the velocity of the fluid over here would be different from the velocity of the fluid over there. What you have to do is you have to find out how velocity of the fluid varies as a function of the distance from the center. That is, if we take an arbitrary radius, let's say somewhere over here, you have to find out what is the velocity at that particular point in both the cases. So you have to find out velocity as a function of smaller, where smaller is the radial direction distance from the axis. We would be solving case 1 for you in the follow-up video. If you understand case 1, case 2 would be very simple, and case 2 hence would be left for you as homework. So try this problem out by yourself. If you are not able to solve them, we would be solving case 1 in the follow-up video. Thank you.